This question is from the topic relative velocity. In this question, it says that a plane can travel at 250 km per hour speed in still air. It sets its direction on a bearing of 070 degrees. At that time, a wind was blowing with W km per hour and its direction is from the south. Due to this wind, the plane gets a bit off course and it travels on a bearing of 060 degrees. It means that the direction of the resultant velocity is on a bearing of 060 degrees. We have to find in kilometer per hour the resultant speed v of the plane and the wind speed w, which will also be in kilometer per hour. Now let us try to understand the problem by drawing a diagram at first. So in order to draw the diagram, we need the north-south lines. So this is north-south line, this is east-west line. Now I need to draw a roughly estimated 70 degree. So this is the 70 degree with the north-south line, and this direction will be the velocity of the plane in still air, and it goes in direction with the speed of 250 km per hour. This is velocity of plane relative to wind, and the wind is actually blowing from the south. That means in this direction upwards. So the wind will affect the velocity, or the relative velocity of the plane, and it finally ends up going on a bearing of 60 degree in this direction. This picture becomes a bit clumsy, so let me draw a clear and bigger picture. So let me draw a clear and bigger picture. So let me erase this first. Okay, now the image is cleared. Now let me draw the lines first. This is my north-south line. I need the east-west line. So let me draw the east-west line. Okay, fine. Now let put the symbols. NS for north-south, east EW for east-west. Now again I need the 70 degree angle, which was the bearing of the plane when the plane goes in still air. So this is the direction of the velocity of the plane relative to wind, and its magnitude was 250 km per hour. So let me put the value 70 degree, which was the value of this angle. This is 70 degree, and the question says the resultant velocity goes on a bearing of 60 degrees. So let's say this is my 60 degree. So the direction of the resultant velocity will be in this direction. Okay, and it also says that the wind blows from the south. So let me connect these two lines, and now let's put the directions of the velocities. This wind will go upwards and the resultant velocity goes in this direction. We have to find the speed of the resultant velocity and the speed of the wind. Okay, now the included angle created by the relative velocity and the resultant velocity is 10 degree, which is 70 minus 60 is 10 degrees. So let's put the symbols to describe the triangle properly. This is O, this is A, this is let that be B. Now we have a triangle as OAB. This north-south line and the AB line is parallel to each other. The angle NOB is 60 degrees. Therefore, the angle OAB is also 60 degrees, as they are alternate angles. So the angle OAB must be 110 degrees. Now we have all the information at our disposal to solve the problem very easily. In order to solve this math, we are going to use the sine rule of triangle here. But what was sine rule? It's usually given in our formula page, but let's revisit the sine rule in a brief here. We need a triangle, so let's draw a triangle. Okay, now let it be our ABC triangle. Let the length of the side BC is A, and let the length of the side AC is B, and let the length of the side AB is C. Then according to the sine rule, we can write A over sine A is equal to B over sine B is equal to C over sine C. Now let's focus on our original triangle OAB. The opposite angle of the side AB is 10 degrees and the opposite angle of side OA is 60 degrees. So using the sine rule, we can write W over sine 10 degrees will be equals to 250. So let me write 250 over sine 60 degrees. So that can be written as W is equal to sine 10 degrees over sine 60 degrees times 250. Now let me take the calculator to calculate this value, and the value is 50.1 kilometer per hour. So the speed of the wind which is blowing from the south is 50.1 kilometer per hour. Now using the sine rule again, let's try to find the speed of the resultant velocity. So we can write V over sine 110 degrees is equal to 250 kilometer per hour divided by sine 60 degrees, which can be written as V is equal to sine 110 divided by sine 60 times our 250. Now let me do the calculation so that we can get the value of V as 271 kilometer per hour. So finally we get our speed of the wind as 50.1 kilometer per hour, and speed of the resultant velocity is 271 kilometer per hour. So we have finished this question. Now let's move on to the next question.